Article 334 covers service entrance cable, types SE and use. Section 334.10 states that SER cable shall be permitted to be installed exposed or concealed, indoors or outdoors, in raceways in accordance with Article 300, or as open wiring in accordance with Article 320. Article 334 does not explicitly address burying SER cable underground in PVC conduit. Article 310 pertains to conductors for general wiring. Section 310.10 states that conductors for general wiring shall be installed in raceways, as provided in this article. Based on these code sections, whether SER cable can be installed in PVC conduit buried underground is not explicitly stated. However, given that SER cable is permitted to be installed in raceways, it should be acceptable to install it in PVC conduit buried underground, provided the conduit is properly sized and installed according to Article 300. To elaborate further on Article 300, it is important to understand its general requirements for wiring methods and materials. Article 300.3 bone addresses single conductors and specifies that all conductors of the same circuit and, where used, the grounded conductor and all equipment grounding conductors and bonding conductors shall be contained within the same raceway. Auxiliary gutter, cable tray, cable bus assembly, cable, or cord. Article 300.5 outlines the requirements for underground installations. These requirements vary based on voltage, burial depth, and the type of raceway or cable used. For instance, Table 300.5 provides minimum cover requirements, which are the distances between the top of the buried cable or conduit and a finished grade. The specific depth depends on the voltage level and the presence of a concrete encasement. For example, direct buried cables operating at 600 volts or less typically require a minimum cover of 24 inches, while rigid metal conduit or intermediate metal conduit may require only 6 inches of cover if concrete encased. PVC conduit containing SER cable would likely need to adhere to specific burial depth requirements outlined in Table 300.5 unless concrete encased. Article 300.7 addresses raceway systems exposed to different temperatures, such as when a raceway transitions from underground to above ground. It requires sealing or other means to prevent condensation from accumulating within the raceway. Condensation can damage conductors and other electrical components. Article 300.11 pertains to securing and supporting wiring methods. Raceways must be securely fastened in place. The specifics on how far apart supports must be varies depending on the type of raceway. Article 300.14 requires that at least 6 inches of free conductor be left at each outlet junction and switch point for making connections. This ensures sufficient wire length for safe and easy connections. Considering SER cable's construction, which typically involves individually insulated conductors within a non-metallic jacket, it is crucial to protect it from physical damage and moisture when installed underground. While SER cable is permitted in raceways, it is essential to ensure the specific type of SER cable is suitable for wet locations if installed in a conduit that may accumulate moisture. The cable's insulation should be rated for wet locations. The National Electrical Manufacturers Association (NEMA) provides standards for enclosures and raceways that specify their suitability for different environmental conditions, including wet, damp, and dry locations. Using an NEMA-rated enclosure or raceway appropriate for wet locations helps ensure the protection of the conductors and connections. Regarding the installation of PVC conduit, it is essential to use the proper fittings and installation techniques to maintain a watertight seal. PVC conduit systems rely on solvent-cemented joints to prevent moisture from entering the raceway. The selection of the appropriate solvent cement and the proper application technique are crucial for achieving a reliable, watertight seal. Furthermore, expansion fittings should be used where the conduit run is subject to significant temperature changes. PVC conduit expands and contracts with temperature fluctuations, and expansion fittings accommodate this movement to prevent stress on the conduit and its connections. When installing a SER cable in PVC conduit, it is also crucial to consider the fill capacity of the conduit. The National Electrical Code specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. This ensures adequate space for heat dissipation and facilitates pulling the conductors into the conduit. The conduit fill requirements are outlined in Chapter 9, Table 1 of the NEC. To determine the appropriate conduit size for SCR cable, one must calculate the cross-sectional area of the conductors and compare it to the allowable fill percentage for the specific type of conduit being used. It is also important to consider the bending radius of the SCR cable when making bends in the conduit run. Exceeding the minimum bending radius can damage the cable's insulation and reduce its current carrying capacity. The NEC specifies minimum bending radii for different types of cables and conductors. In summary, while the NEC does not explicitly prohibit the installation of SCR cable in PVC conduit buried underground, several factors must be considered to ensure a safe and code-compliant installation. These factors include the suitability of the SCR cable for wet locations, the proper installation of the PVC conduit system, adherence to burial depth requirements, the use of appropriate fittings and expansion joints, and compliance with conduit fill requirements and bending radii. Always consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. The goal is to have a safe installation. Firstly, it is important to check if the SCR cable is rated for wet locations. Secondly, ensure the PVC conduit is installed correctly with proper fittings. Thirdly, consider the burial depth requirements outlined in NEC Table 300.5.